Hello again, everyone. We will start this LLM track with a talk about open source ML from pre-trained model to production. And for that, we will have Omar Sanseviero, who is machine engineering lead at Hugging Face, who is actually CEO, just testified in front of U.S. Congress. Hello, Omar. How are you?
Oh, good. Thanks. How are you?
We're doing well. Yes, thank you. Open source is extremely important, and especially in machine learning, AI, and LLMs. So let's see how we can go from pre-trained models to production. And yes, and we're really glad to have you there.
Awesome. Yeah, thanks. Yeah, let's get this started. So yeah, hi everyone. I'm Omar. I'm a ML engineer lead at Hugging Face, working in the intersection of open source, product, and community. So today I will talk about open source end-to-end, from pre-trained models to putting the models in production. This is a very complex topic, so of course there is no way I will be able to capture all of this in just 25 minutes. But the goal today is just to increase the awareness of which are some of the existing tools that can make it easier to use state-of-the-art models in your own products, services. All the things I'm going to talk about today are open source, are free. None of this is a paid product, so just a disclaimer. So I'll divide the talk in 4 parts. First, we will talk about how to find the models out there. So if you are already a Hugging Face user, the first 2-3 minutes will be a bit obvious to you, but after that, I will be sharing some very interesting things. After that, we will be talking about how to run inference of large language models, and then we'll see how to adjust the models for your own use cases. So if you're not familiar with Hugging Face, it's a collaborative platform for machine learning. It has 3 main pillars. So you can access a huge amount of models and datasets shared by the community. And the community here can mean the whole open source community. So you can see large companies, so Google, Microsoft, Meta, for example. You can see research labs from universities. So you can think from Stanford to many other thousand universities. And finally, there are also open source communities. So Eleuter AI, Lion, Open Assistant, which are open source communities that are doing interesting open source replications. So that's one of the ways in which Stable Diffusion came out there. There are the GPT Neo X and a bunch of other models that have been out there in the last couple of years. The third pillar at the Hugging Face is called Hugging Face Spaces. It enables people to build ML apps and demos and showcase what they are working on, and can also support building production services. Maybe you already knew some of this. What is quite exciting is to see the growth. So I put here some of the numbers from 6 months ago. So this is from the beginning of January. And you can see that the usage has increased significantly. So 100% for models, but you can also see that Spaces, for example, is 3 times larger now than 6 months ago. It's very exciting because this is just a huge explosion of interest in open source and many more people, companies, groups collaborating in some way or another in the open source ecosystem. For the sake of the first part of the talk, what we care more about is the model hub, so the first pillar. So you might know that Hugging Face has created some popular Python libraries. So the most popular one is called Transformers, and another popular one is called Diffusers. These libraries allow you to use pre-trained models by people in the community. So with a single line of code, you can load a transformer model shared by Google, for example. These libraries are very well integrated into the hub, but our goal is not to do a lock-in system in which everyone needs to use our libraries. So what we have done in the last couple of years is build integrations with many different open source libraries. So Spaces is a very popular NLP library, SpeechBrain is a very popular audio, and then we have done integrations with 20 to 30 different very popular open source libraries, really to enable anyone doing open source machine learning to collaborate. And although Hugging Face origins come from NLP, we also have support now for many modalities. So we have support for computer vision, reinforcement learning, tabular data, multimodality. And users now can find models filtering by these modalities, and they can find model cards, which is pretty much documentation, it's essential documentation artifacts that help people understand what's the model, how it was trained, but also do more let's say, rigorous scientific sharing. So for example, if you want to report metrics, it allows people to benchmark and compare different models. You can report even things such as CO2 emissions to report what was the CO2 emission when training the model. So I just wanted to briefly cover that part, but I would like to share some of the more recent things that are going on in the ecosystem. So everyone these days wants to run inference of some very, very, very large language models. So let's dive into it. So in the last couple of months, every few weeks, or even every few days, and sometimes every few hours, there are some very new exciting models. I put three examples of popular recent models, but there are really few of these every month, but these are three quite large ones. So the first one, StarCoder, is a open source community-led co-pilot replication. It's trained with permissive code, which is quite interesting. It supports dozens of programming languages. The second model, Llama, most likely you have heard about this. So Llama is a large language model for Meta, which was released and then was leaked as well, because at the beginning the way to access the model was through a gating mechanism, and it was leaked. But what has been quite exciting is that when it was released, it was the best open source model. So there was a huge explosion of tools and research built around it. So there's a thriving ecosystem that popped out thanks to it. So there are people doing C++ ports to run the models directly on device, to people doing many interesting fine tunes. And the third model, Falcon, is very, very recent. It's three or 4 weeks old, I think. It's a state-of-the-art, fully open source model. So this one has an Apache 2 license, which is more open. And yeah, metrics-wise, it's quite good. It's multilingual, and there are like two different sizes, so 7 billion parameters and 40 billion parameters. So the previous slide showed some common things. So for example, the model size can be huge, right? Like if you look at the number of parameters here, it's quite large compared to a few years ago. Falcon, for example, requires a lot of memory. So it requires having a 90 gigabytes of GPU. And the issue is that there is no common GPU, like A100 doesn't have 90 gigabytes, right? So it makes it very, very hard to use the model because it won't fit in a single machine. So making it work is possible, but it requires handling some complex parallelism and communication among the GPUs. It's getting better and better, but it's tricky. It's not as straightforward as running a small model. Apart from the core inference side of things, the evaluation is also quite challenging. So there are many existing benchmarks, but they are not necessarily representative of the real world usage. So for example, most benchmarks are based on a single turn on a conversation, right? So just the first response that the model returns. But in real life, people have multiple turns. They have a long discussion. So you could potentially do evaluation of a full conversation after multiple turns and then compare among different LLMs, but that's very expensive and it's very time consuming. And that's one of the things that the ecosystem has not figured out yet. Not just the open source ecosystem, but the whole scientific ecosystem around large language models. But it's also very important for any company that wants to use these models, because comparing the models and doing quality iterations is essential, right? And then the users and companies, they will want the models adjusted for their own data, for their own needs. So then you also have many discussions about fine-tuning, which I will talk about in 5-10 minutes. And finally, you need to do a bunch of optimizations because you want to have extremely fast inference, extremely fast latency, depending on the use case. So for example, if you are working in ChatGPT, what you will want is to optimize for user perceived latency. So user perceived latency means what's the latency that the users perceive. So for example, rather than returning a whole paragraph, if you use ChatGPT, it will be returning a couple of tokens, a couple of characters as it's being generated, right? So it gives an impression that the model is working fast rather than having to wait for 30 seconds before getting a reply. Okay. So there are many things that the ecosystem has been working on in the last couple of months, years. So there are some tools and techniques that you can use to work around this. So for example, there are techniques such as loading the model in 8 or in 4-bit mode that will allow you to run the models with significantly less memory. You would have a very, very minor quality hit, but it would allow you to run the model. So for example, you can use the bits and bytes and accelerate libraries to run the large Falcon model, the one that would require around 90 gigabytes of RAM of GPU. And then you can use just 27 gigabytes by running in 4-bit mode. So that's quite exciting because it really lowers the barrier of starting to use these models, at least just for inference, quite a bit. With accelerated library, you can also do other kind of stuff. So for example, if you want to run the model in multiple GPUs, you can do that. It's a bit outside the scope of what you would likely want to do. But for example, if you're extremely memory limited for some reason, you can potentially even offload some of the computation to the CPUs. It would be very, very slow, but it's possible. So that's quite interesting. And finally, there are tools such as a new tool called text generation inference that are optimized to run inference of large language models. So I will talk a bit more about this specific tool. So it's an open source tool. It was created by Hugging Face. It's in GitHub, so you can go right now and check the code. I will refer to it as TGI, text generation inference. And TGI is really a toolbox that has combined many of the things that have been discussed in the community in the last half year, 1 year. It has, I put here the top 6, but there are many other things here. So for example, it has support for tensor parallelism, which allows you to run very fast inference on multiple GPUs. So pretty much the inputs, the tensors, will be sliced and processed by different GPUs. So that's pretty much it. Before I was talking about token streaming. So that's pretty much that rather than waiting for the full generation, the server will start replying, giving responses as soon as you have some part of the generation. So that provides a much faster UX. Then there are quantization tools such as bits and bytes, which I mentioned before. And then there are many optimizations to run fast inference. So there is flash attention, which is a somewhat popular recent mechanism to do attention, which is, I mean, don't worry if you don't know what attention is, but it's core to the transformer model. So there are techniques to accelerate it. And TGI has support for some of the most popular LLMs, so Falcon, Llama, Galactica, StarCoder, SantaCoder, many of the GPT open source replications. And it's being used quite a bit out there. So for example, Hugging Face created this thing called Hugging Chat. Hugging Chat is a UI open source UI for open source large language models. So that's powered by TGI. Open Assistant is a community doing an open source replication of ChatGPT. They are also using this to do inference of their existing models and to label data and to iterate on the quality. And Nat Friedman, a few months ago, released a LLM playground that's also powered from the open source side of things by TGI. So we have had quite a bit of battle testing out there in production, and at least for some of these demos, models that have been quite popular, we have built demos running with this behind. So we have lots of benchmarks, and I'm happy to share more resources later about this. But now that we talked about how to run existing models, most likely if you're at a company, you will want to train the model. There's a huge asterisk here because sometimes we jump directly to train models, and that might not be actually what you want to do. But it's good to know what's out there in case you actually need to fine-tune or train your models. So most people are familiar with the classical ML setup, in which you train a model. In the context of large language models, you will require a huge amount of data, a huge amount of compute, and probably you will require like very good expertise in your team to be able to train a high quality model from scratch. In the last 6 years, many people have been doing fine tuning, which requires picking a base model. So a large language model that was shared by Facebook, for example, with Llama, or BERT by Google, or GPT-2, or like one large language-based language model, which would usually be very expensive to train if you were doing it from scratch. But you can adjust or fine-tune to your own domain or your own data with much less data and compute. And that has been the paradigm in the last few years, and it has worked quite well. That's also why we have so many models on the hub, because many people are not just sharing new models from scratch, but also many fine tunes. What has received quite a bit of popularity and visibility this year is something called PEFT, parameter efficient fine-tuning. So PEFT takes this even further. It requires much less compute. It enables fun use cases. So for example, you can fine-tune models such as Falcon, the small variant, not the large one, or Whisper in Google Colab for free. PEFT, the idea of PEFT is that you will only fine-tune a small number of additional parameters. So imagine that you add a small adapter, a small couple of layers to your model, but you will freeze entirely the base model. So that means that when you train, you don't need to adjust at all the base model. So you just need to adapt a bit the model that you're adding. That means that you can improve the quality of the model by just training a very small portion of the final result, right? So it will add a bit of memory, so it will make the whole setup a bit larger, but it will not have lots of impact. Let me show you three examples or two examples. So Whisper is an automatic speech recognition model released by OpenAI last year. Automatic speech recognition means that it's a model that will transcribe audio files. So the input will be audio and the output will be text. So fine-tuning Whisper in general is not super easy. It requires very good compute. But there is this technique called LoRa, which is one of the techniques under PEFT, under parameter efficient fine-tuning, that would allow you to just add a small adapter, which is much smaller than the original model, and enable much faster training. So you can see the numbers here. So thanks to LoRa, you can train an adapter, which is just 1% of the size, and it will allow you to have batches 5 times larger. So that means that the training will be much faster. You can run this in a consumer GPU, so most likely in your own computer, and you will have results that are on par with what you would get by fine-tuning the whole model, which would be more computational heavy and a bit harder technical wise. You would have a very small quality hit, so the quality would be slightly, very slightly smaller, but it depends a lot on the use case. So there's still quite a bit of work to be done around here. So PEFT can also be used for other things. So for example, for stable diffusion, which is a very popular open source image generation model. So for historical context, LoRa was proposed by Microsoft in the context of LLMs, but people have been able to use it for other modalities. So I mentioned Whisper before, which is audio, and thanks to this work, the community has been able to do the same for stable diffusion. So you can train stable diffusion with much lower compute requirements and with very small training weights. So for example, Dream Booth is a technique to, let's say, adjust stable diffusion for your own data. So you have probably seen these demos in which people upload 6 pictures of themselves, and then stable diffusion is able to generate images with that person or with their pets or whatnot. With Dream Booth, usually you would have as an output a huge model, right? So sharing these models is not super easy. And if you have 10,000 people doing this and you have 10,000 large models just for a small adjustment, right? So you could perform LoRa here, and the output would be a model of 3 or 4 megabytes. So it's tiny, it's small. So that means that you could even have in a single demo Dream Booth Inference with 100 different fine-tunes, because each of these fine-tuned models just weighs 3 megabytes, and all of them share the same frozen base part. So that's quite nice. And there was this technique, it's very recent, it's just 1 month old, called QLoRa. So it allows you to do efficient 4-bit quantization and adapter tuning. Sorry for the amount of jargon, but pretty much the idea is that it would allow you to do PEFT even faster. So for example, in the context of reinforcement learning with human feedback, which pretty much the goal is to introduce the human feedback, the human labeling into the model, you could have a single base model and then multiple adapters. So if you know RLHF, there's a preference model, for example, and a couple of other models, so you could share the same base model. I won't enter into the details of QLoRa. Again, I'm very happy to share resources after the talk, but it enables very exciting things. And yeah, so today what we talked about so far was how to find open source models by the community. We then talked about how to run inference with them. Then we talked about how to do efficient techniques to adjust the model. So we talked about PEF for your own data, for your own needs. So just to close the talk, I would like to talk very quickly about how to build and share machine learning demos. So why do we care about demos? Demos allow you to easily present to a wide audience of people. So it increases the reproducibility of the research. It enables people from diverse backgrounds to play with and debug your model. So the implications can go further. So for example, you can use demos to showcase to stakeholders. You can show impacted people from other disciplines from a very early stage in an ML life cycle. So let's say that you want a model with some medical application. So you could create an ML demo, an ML app, and show it to doctors and see how they interact with the demo. So of course, that would not be a final product, but it enables you to have very early validation that rather than working for 2 years in something that afterwards might not be used at all. So there are many popular demos out there. So you have probably seen these ones at the left. You can see Stable Diffusion. At the right, you can see DALI Mini, I think, from a year ago. So these were two of the most popular ML apps that were created. They are open source, so that means that anyone can go and contribute to it. And yeah, all of these were created with a library called Gradio. So Gradio allows you to build nice ML apps with very simple Python code. You can run them locally. You can run them in a Python script. You can run them in Python, in Jupyter, in Colab, and you can host them in Hugging Face spaces for free if you just want to run on a CPU. But again, you're not logged in, so that means that you can also host in your own servers or wherever you prefer to host things. So here what you can see is at the left is a very typical code snippet of this. So Gradio is very minimalistic. There are two different modes. One is called blocks, which I won't talk today, and the other is called interface. But the idea of interface is that you just specify what's the input, what's the output types, and what's the inference function. So here what you can see is that you have a Gradio interface. You have a function called classify image, which is the function that will run the inference, which will receive an image as an input and will output a label, right? And at the right, you can see that, right? You can see the user is uploading a picture of an American alligator, and at the right, you get the prediction of the model. The nice thing is this function, classify image, can be any Python code. It's arbitrary Python code. So that really means that you can have anything here. So if you use scikit-learn, you can use scikit-learn. If you use TensorFlow, you can use TensorFlow. Whatever is your tooling, you can build a nice ML demo here. So it's very exciting because what we are seeing with spaces, with Gradio demos, is it's a turning point in usage of ML. So until 2 years ago, 95% of people interacting with models in a UI were ML engineers. Then you could see more software engineers. But in the last year and a half, we are seeing anyone with a web browser, anyone can play with these models. So that's how we've seen many of these models going viral. ChatGPT is also a good example of this. It has a very good UX, so it has really lowered the barrier of entry to try out these models. So yeah, I think all of this is quite exciting. My goal today was mostly to give a high-level overview of all of the tools and recent topics going out there. I'm happy to share more resources afterwards, and I hope this was useful. Thanks.
Thank you very much, Omar. We have some questions about people interesting to host their own models and build their own models. So you said in your talk that it's still difficult to build your own models. What team do you advise to hire to build your own model?
Yeah, that's a good question. It depends a lot on what you're trying to do. I think that one of the challenges right now is that the expectations, the base expectations we have now compared to a year ago are also much higher. That means that you would likely require very high quality data. I think having good data and good infrastructure around all of this is quite essential to train. Like if you want really good models in a production setup, you will want a good mix of infra skills and data skills. A skill set I think is quite interesting is more of a classical, so not a ML researcher, but more of a classical, which is also essential here, by the way. But what there is a strong lack right now is software engineers that have a good understanding of machine learning and can do. There are a bunch of infrastructure and technical challenges around running and training these models. So yeah, I think that kind of skill set can be quite powerful right now.
We have another question. I think based on 4 weeks ago, there was a leaked memo, probably leaked memo of Google saying that open source models will actually, there is no goat and there is no
Mhm.
moat, right? So open source models are so prolific that even like people who were started early, like Google Bard or ChatGPT and stuff, doesn't have enough advance to fight against the open source community innovation.
Mhm.
With Hugging Chat, with Hugging Face, and all the models you see. Like, do you agree with that memo?
Uh, I don't entirely agree. I think that the incentives, the capital, and there are many factors that are quite different. The training models is getting more and more capital intensive. I, yeah, I also think it's important to consider that lots of the things we have seen open source in the last few months were based on Llama, which was a model released by Meta, right? So I think that what we'll see is a synergies between both. I think that there will also be many challenges from the open source side of things to put these models actually on production, and there's lots of technical work to do there. But what I am seeing though is usually you would have like a big gap in the time from the moment in which a company like has some internal model in research side and you would see a model with similar quality. I feel the time in which this like the current gap is getting closer and closer. So right now you are seeing the open source ecosystem moving much faster compared to 4 years ago.
Yeah, it seems many researchers were doing. Yeah, it's really a researcher-driven, like public research-driven ecosystem. So a lot of researchers are used to publish things open source and publicly. So
Mhm.
yeah, this is why we may have more open source things than in other like systems.
Yeah, yeah.
Thank you very much, Omar. Thank you for this presentation. I hope it inspired a lot of people to start consuming AI or building AI or your own models. And yes, I invite everyone to go on Hugging Face to discover open data sets, open models, and everything.
Yeah, thanks
Thanks,
a lot for
Omar.
the invitation. Thanks everyone.